Okay, in today's lesson, we're doing lesson 9.10, and we are still solving nonlinear equations, as it says up here, but this time we're solving them algebraically. So we are not going to use the graphs. Again, graphing would work if you set these equations both equal to y, but we can do all of this just by hand, algebraically, and we can use substitution or elimination. And the first one we're going to discuss is the substitution method. Now, this isn't new. Okay, you've done substitution and elimination with systems in Algebra 1, but now we're just doing them with nonlinear systems, meaning, again, that like one of our equations, we can have an x squared, we can have parabolas, we can have circles, hyperbolas, ellipses, etc. Okay, before you've just done them with linear equations. But I will say the substitution method, it's going to be usually the most effective. Like this will be the one that you choose probably the most throughout your assignment, and we will also throughout our notes. All right, with substitution, we need at least one of the variables solved for. Okay, I'd like to start with either x equals or y equals. And if it starts with that, then we can plug it into the other equation. Because here's the deal. When you are solving a system, okay, in this system, we are in two variables. We are in x and y. We need to know what x equals and what y equals. And then we'll write that as an ordered pair, okay, our answer. But you can't get an answer for x and y if your equation is in terms of those two variables. You need to get it in terms of one letter, and then you can solve for that one variable and get a number answer. All right, so we have to use substitution or elimination to make that happen so that we can get it down to those number answers. And if you notice here, look at the second equation. The second equation right here, it says y equals, and y is equal to x squared plus 5x minus 2. Well, if y is equal to that, then we can take that and we can substitute it in for y in the opposite equation, and that puts everything in terms of x. All right, we're substituting in an equation just like we substituted a number value, okay? Just we're adding more algebra to this. So let's solve what we have now. Okay, so we have, I'm taking that 4x, and then plus, I'm substituting in for y. So I'm substituting in right there, it was just x squared plus 5x minus 2, and it's equal to negative 20. So right here, oh, not that, right here is where I took what y was equal to and I substituted it in for our y value in the opposite equation. Okay, so you take one and you substitute in the other sometimes. Okay, there's other ways to do substitution. This is just one way. Now, because there's no number in front of the parentheses, we do not need to multiply, so we can just drop the parentheses and we can combine our like terms. So that will be 4x and 5x. Okay, and here's my equal sign. And I am also noticing at the same time that x is squared. It is quadratic. So that means we need to get this at equal to 0 for our solving. So we have x squared plus 9x minus 2 equal to negative 20. Again, because it's quadratic, we need it equal to 0. So we're going to add the 20 over. So we have x squared plus 9x and negative 2 plus 20 is equal to positive 18, and it's equal to 0. Again, because this is quadratic, we need to do a factoring to separate our x's or to get our answer here. So we're going to do our 1, 2, 3 factor tree. What multiplies 18 and adds to 9? Those two numbers will be 6 and 3. So we're going to write this in factored form. Okay, x plus 6 times x plus 3 equals 0. And to pull our solutions out of there, we have to t-bar. We set each side equal to 0 and solve for x. So we get x equals negative 6 and x equals negative 3. So notice we have two answers for x. So we're actually going to have two ordered pairs for our answer. Okay, we have negative 6 and negative 3 for x. So now we need to find out what y equals. So we're going to go back to that second equation we had that started with y equals, okay, right here, y equals x squared plus 5x minus 2, and we're going to substitute in each of our x's. All right, so let's start off. We're going to say y is equal to, and we're going to start by plugging -6 in for our x's. So -6 squared plus 5 times -6 minus 2. We also need a second answer by plugging in -3 for x. So -3 squared plus 5 times -3 minus 2. Now each of these just get typed into your calculator. Okay, so take a second to get that done. Okay, the top one, when you plug in -6 squared plus 5 times -6 minus 2, we get an answer of +4. All right, so that makes an answer of -6 and 4, an ordered pair. If you graph this, you would see it would be intersected at these points like we saw yesterday. Our second equation down here, -3 squared plus 5 times -3 minus 2 equals -8. So we created an ordered pair of -3 and -8 as our answer. Okay, so there were two answers, okay, because what we had here was a parabola and a linear equation, and they intersected twice, and they would be at those 2 points. All right, on this next problem, we still have a system of equations. We have 2 different equations. So we have y equals x squared plus 3x plus 2, and notice that this would create a parabola, a happy parabola of sorts. And then we also have y equals x squared plus 5x minus 4, which is also a quadratic or happy little parabola. And what we're going to do is see what the solutions are. Remember also that there could be 0 solutions, 1 solution, or up to 2 solutions, 2 crossing points. And we can see what this one's doing without looking at the picture of the graph by solving it algebraically. And the method that we are being told to use here is elimination. Remember, because we're trying to get an ordered pair as our answer, okay, like an x and a y number for each, these are number answers, we have to get these equations in terms of one variable, only in terms of x or only in terms of y. So we have to change them somehow. Elimination means we are going to eliminate or get rid of either the x's or the y's. This method works well when you have matching coefficients and then you get them to have opposite signs for a variable. So if you're looking, okay, let's look here by why this one works well for elimination for this one. The y's in either equation, they both have the coefficient of 1. And if I could get them now to have opposite signs, they can eliminate or cancel out. We cancel out to 0, okay, when we add the equations together. Also, when you're doing elimination, you are adding the 2 equations together. So right now, if I added the 2 together, right now, this would make 2y. And we don't want them to make 2y. We want them to eliminate or add to 0. So we can manipulate one of the equations by multiplying one of the equations by like -1, because 1 and -1 would add to 0. So what we're going to do here, I like to change the bottom one. It could be the top or the bottom, but I'm going to multiply the bottom equation by -1. And I'm going to write over here to the side what that makes everything. We have -y is equal to -x squared minus 5x, but plus 4. And I do not need to change the top equation, so I'm just going to copy it back over. This was y equals x squared plus 3x plus 2. So again, what we're doing here with elimination is we are adding, okay, by column, we're adding the 2 equations together. We're combining our like terms. Notice that all of our terms are in columns. They are already grouped with their like term. And what happens is when I add them together, okay, this is the special thing that we're looking for to happen with the elimination method, is the term that I'm eliminating, my y minus y, that now equals 0. All the y's are now gone. And for this problem, it just so happens that when we do x minus x squared, those also cancel out to 0. But we do still have regular x terms. We have 3x minus 5x equals -2x, and 2 plus 4 makes 6. So now I look at it. I'm asking again, linear or quadratic. This is a linear equation. Here's my x right here, and it is just the first power. So to finish solving this one, I'm going to add 2x to both sides to get them on opposite sides of the equal sign, my variable term and my constant term. We have 2x equals 6, and to finish it off, we divide both sides by 2, again, because this is a linear equation. So x equals 3. Now notice I only got one answer for x. So that means I'm only going to have like one solution here. Okay, we have the x value is 3, and now what is the y? To find the y answer, you can go back to either of your equations here, and I'm just going to select my top equation. It's usually easier to use that, and I use one of my originals because I can see more clearly just what it is. But I'm going to plug in 3 for each of my x's up here. All right. So wherever there's an x, I'm plugging in 3 because that's what x is equal to. So let's kind of go off to the side here. We're going to say y is equal to 3 in parentheses squared. We always use parentheses when we substitute in a variable. Plus 3 times 3 plus 2. And what does that equal? Okay, type it into your calculator or do mental math. 9 plus 9 plus 2 is equal to 20. So I come back up here. Okay, I'm writing my answer as an ordered pair. These intersect at the point 3 for x, 20 for y. Okay, and that was using the elimination method. I, for the most part, think that substitution usually works better. And we're going to see another way to work substitution here on our next problem, but it is up to you. You get to choose elimination or substitution. Substitution kind of like always work. Elimination has situations where it will work like more fluidly, easier, but it's not always like the most easy choice. Okay, on our example number 1, notice over here it says solve each system algebraically, so we're not going to type these into our graphing calculator. And it says use the method of your choice. And I come and I look at my equations. I have y equals x squared minus 3x minus 2, and I also have y equals x plus 3. I am going to use substitution on this problem. All right, this is the method I'm going to use. I'm going to use substitution. And I'm going to show this one a little bit different way because both of these equations start with y equals. Okay, they both start y equals. Because our y is equal to x squared minus 3x minus 2, but this same variable y is also equal to x plus 3, these two parts that I have highlighted in yellow must therefore be equal to each other. All right, or we're kind of substituting one y into the other, like x plus 3. So those two parts that are highlighted in yellow are also equal to each other, and I'm going to set them up like this. We have x squared minus 3x minus 2 is equal to x plus 3. All right, so those two highlighted parts, I made an equation out of them. And I'm looking at this equation, and notice that this equation is quadratic. X is squared. So to solve for x, we need to get it set equal to 0. So we're going to subtract x from both sides and subtract 3. Match them up with their like term. So this is now x squared minus 4x minus 5 equals 0. So to solve this, we'll do 1, 2, 3, our factor tree. What multiplies to negative 5 and subtracts to negative 4? We have negative 5 and positive 1 that fit our puzzle. So we write it in factored form. X minus 5 times x plus 1 equals 0. And then we t-bar it, as we know, and we get the opposites that come out solved for x. So x is equal to 5 and x is equal to negative 1. Now, notice we are not finished with this problem. When you solve a system, you need to write your answers as an ordered pair, like x comma y. But what we just found were two x's. So we have x is 5 and x is negative 1. So what we need to find now is the y's for each of these equations. All right, there's two answers here. So now I'm going to look at the top two. It doesn't matter if I choose like the top equation or the bottom equation, but I am going to use this bottom one, y equals x plus 3, just because it's more simple. It doesn't matter which one I plug into, I'll get the same answers for y, for 5 and for plugging in negative 1. But I'm going to now use, okay, y is equal to x plus 3. I'm using that equation, kind of working over here. And first I'm going to plug in 5 for x. So for 5, okay, y is equal to 5 plus 3, which equals 8. So when x is 5, y is 8. That is a solution. That's one of my solutions. And then I'm going to plug in negative 1 for x. So we're going to say y is equal to negative 1 plus 3. I'm using that same equation to plug into for x right there. Negative 1 plus 3 is 2. So when x was negative 1, y was positive 2. And those are my two solutions that I got. Again, solving algebraically, solving with the method of substitution. Okay, number 2, here's our system. We have y equals negative x squared minus 8x minus 6. That's a little sad parabola. And then we also have 2x plus y equals negative 1. Now, there are two different ways to apply substitution, which is, again, the method I'm going to use. This is not lined up correctly for elimination. It'd take a lot more work to make elimination be fast and effective here. A lot of people like doing substitution when both sides are equal to y. So while there are two methods here for substitution, I'm going to solve it and set it up like the last problem. The first equation here is already set up with y equals. The second equation is not. Okay, so we want it to start y equals so that we can set these two equations equal to each other like the last problem. So the first equation is fine. The second equation, I'm going to subtract 2x from both sides and then rewrite this as y equals like negative 2x minus 1. Okay, and I'll think of that second equation in this form. Now again, kind of like last time, because they're both equal to y, okay, they're both starting with y equals, that means that negative x squared minus 8x minus 6 has to be equal to negative 2x minus 1. So that's how we're going to set this up. I am essentially substituting in negative 2x minus 1 in for the y in the opposite equation. And that will look like here, negative 2x minus 1 equals negative x squared minus 8x minus 6. Okay, so I look at this equation now. Here's my equal sign. This is, again, quadratic. Right here, our x is squared. So that means I need to set equal to 0, and then I will probably end up factoring and t-barring. But I do not like to have my quadratic be negative. So I'm actually going to move everything to the left side here. So I'm going to add x squared over to the front. I'm going to add 8x. It matches with negative 2x. And add 6. It matches with negative 1. So we have here x squared, negative 2 plus 8 makes positive 6x. Negative 1 plus 6 makes positive 5. And now it's all equal to 0 because everything's on the same side. It is still quadratic, so we need to do our 1, 2, 3 factor tree. What multiplies to 5 and adds to 6 will be 5, positive 5 and positive 1 this time. So write again in factored form, x plus 5 times x plus 1 equals 0. We're going to t-bar it to pull out our solutions. So we get x equals negative 5 and x equals negative 1. Again, these are both answers for x. So again, we're writing our answers in the form of xy. So we have an answer that's negative 5 for x and an answer that has negative 1 for x. We need to know the y value, that's a question mark, for each of these terms. So we're going to go back and we're going to plug in the solutions. I would say that the fastest equation to plug it back into is this one that I'm underlining here, y equals negative 2x minus 1, because it's set up to tell us what y equals. Okay, so y is equal to negative 2x minus 1. Once we plug in for this x right here, each of our answers, negative 5 and negative 1, will be set. Okay, so let's test negative 5. We're saying that y is equal to negative 2 times negative 5 minus 1. So that becomes 10 minus 1, which is positive 9. So I'll go back to my ordered pair that I was starting to build with my answer. When x is negative 5, y is positive 9. Okay, now we need to plug negative 1 in. So we're saying y is equal to negative 2 times negative 1, which would be positive 2, minus 1 is equal to 1. So we have another ordered pair when x is negative 1, y is positive 1. So this one also had two solutions. Okay, make sure again you're writing all your solutions as ordered pairs, just like this. All right. All right, example number 3. We have 3x minus y equals 7, and y equals 2x squared plus 20x plus 46 as our system here. Again, notice this is not like aligned properly to do the elimination method, so we will be using substitution again. And to just make substitution a little nicer here, I'm going to look at this top equation, and I want to get it solved for y. So I'm going to start by Okay, let's look right here. We have 3x minus y equals 7. I'm trying to isolate the y term, so we need to subtract 3x from both sides. So this is now negative y equals negative 3x plus 7. And then to finish isolating that y, we need to divide everything by negative 1. So this becomes positive y equals positive 3x minus 7. And I'm just going to write that over here. All right, so that's how I'm thinking of that top equation. And now because they both are equal to y, right, they both start y equals, that means that what follows are also equal to each other, okay? Or we're substituting one equation into the opposite y. However you want to think about it. So let's set this up. We have 3x minus 7 is equal to 2x squared plus 20x plus 46. Now this is a quadratic equation, so we need to get it set equal to 0. And the 2x squared is already positive where it's at, so I'm going to subtract 3x from both sides and add the 7 using my opposite operations. So this is 2x squared, 20 minus 3 is positive 17x, and 46 plus 7 is positive 53. And this is now all equal to 0. Okay, now we need to solve this equation. Okay, we're going to try to factor it. It would be a slider. Okay, we're going to slide and multiply 2 to the 53. So x squared plus 17x plus 106, 2 times 53, equal to 0. So now we would be looking for two numbers that two positive numbers that, because these are signs are both positive, that multiply to 106 and also add to 17. Now, again, this is a video. If I was in class with you, I'd make you really struggle to try to figure out what these two numbers are. And there actually are not two numbers, okay? There's not going to be any two numbers that multiply to 106, okay, and then also add to 17. So this is not factorable. It's not everything can be factored. And really, you would have just come to figure that out, like, as you were struggling to like find those two numbers and like not ever getting there. Okay, so it's not factorable, and what that means is this is no solution. All right, and then if you did want to double check this problem, okay, you could go to your y equals on your graphing calculator, and you would see that this linear equation that we have from 3x minus 7 and our parabola, they just never intersect, and that's what it means when we get that no solution. They're not intersecting in any way. All right, number 4. We have x squared plus y squared equals 18, and y equals x minus 6. Guys, what we have here, because we have x squared plus y squared, and it equals a constant, x and y are both squared. Remember, that makes a circle. And then we have over here y equals x minus 6. This is a diagonal line with a positive slope. Whenever you're dealing with a circle, do not try to solve for y. Okay, that makes a huge mess. All right, we're not going to do substitution where we have them both in terms of y equals. So what I'm saying is do not do this. Do not take this x squared plus y squared equals 18. Do not try to subtract x squared and have y squared equals 18 minus x squared. You'd have to square root both sides, because you would need it in terms of y, and you'd have this. Messy. This is such a mess, and no, don't try it. I'm not there in person to tell you about this more, but just don't do it. Do not do that. Okay, how are we going to apply substitution then? Because we are going to use substitution. Because we already know right here that y is equal to x minus 6, we are going to take this x minus 6 and substitute it in for the y in the opposite equation. Okay, instead of just substituting a number, we're substituting in two variables. So that would look like this: x squared plus, and here's my y. Remember, it is squared, and we're putting in there x minus 6. We're just dropping it in for y, and it's equal to 18. Okay, so now notice everything's in terms of x, is in terms of one variable, so we're really golden here. And we're going to finish solving this. Also keep in mind, because this is x minus 6 squared, we have to FOIL here. You cannot just square what's inside the parentheses. So we're thinking of this as x squared plus x minus 6 times x minus 6 equals 18. So we have to FOIL it out. We have x squared plus x squared minus 6x minus 6x plus 36 equals 18. Okay, I just did all the FOILing right there. And it's quadratic, so we need to get it set equal to 0 and combine all of our like terms. So x squared plus x squared make 2x squared. Negative 6x and negative 6x make negative 12x. And we'll subtract 18 over from 36 because we want this set equal to 0. 36 minus 18 is positive 18. And now it's all equal to 0. Okay, on to factoring. Because we've got a 2 in front of x squared, okay, we need to get rid of it. This is not a sliding situation. We have a GCF of 2. It divides out of each term, so we pull out to the front, and we're left with 1x squared minus 6x plus 9 equals 0. So now we can apply our factor tree now that our coefficient is 1. What multiplies to 9 and subtracts negative 6? And that will be negative 3 and negative 3. So we will go and write this in factored form. So 2 times x minus 3 times x minus 3 equals 0 and t-bar. Now because this 2 does not have an x attached to it, we just get to cross it off. 2 does not equal 0. All right, and this comes out as x equals 3 and x equals 3. So even though we wrote down x equals 3 twice, we only need to use it one time. Okay, there's only one solution here. You really can't get the same number like twice for x and expect different results. All right, so we are building our answer. I'm going to kind of come up here for my answer. I'm running out of room. Okay, my answer. We know that x is 3. What is y? So let's go back. I'm going to use that highlighted yellow equation right here to find my y. Y is equal to x minus 6, so it's equal to 3 minus 6. And 3 minus 6 is negative 3. So that finishes up our ordered pair right there. When x is 3, y is negative 3. All right, next up is number 5. We have y minus x squared plus 75 equals 0. Now notice y is squared and x is squared. Do not try, again, do not try to solve for either x or y on this one. We're just going to kind of leave it alone. And then our second equation, we have 2y minus x equals 0. And I want to use substitution again. And you can force elimination if you like it a lot, but none of these have been set up super ideally for elimination. And either y or x need to be solved for. The easiest one to solve for is the variable that does not have a number in front of it. Now, it doesn't have a coefficient. So x, I want to get that x by itself. I want this to start like x equals, and I can do that very quickly by just adding x to both sides. And then we have x equals 2y, because that's what 0 plus x is just x. All right, so substitution here. Notice we're starting with x is equal to 2y. So that means I'm going to take that 2y in the second equation, and I have to plug it in right here for the x because it's equal to x. So we have y squared minus, notice there's our x. We put 2y in the parentheses for the x. It is squared on the outside, plus 75, and it's equal to 0. Okay, that's what it looks like when we use our substitution here. Again, I solved it for x, so I had to plug it in for the x in the opposite equation. So we have y squared minus, now this is a monomial inside the parentheses, so I can just square the 2y. It is 4y squared plus 75 equals 0. It is a quadratic here. But see what happens when we put together our like terms. Y squared minus 4y squared is negative 3y squared. And being plus 75 equals 0, because we do not have a regular y term, right? We don't have that b value. Square roots method works on this one, which makes it a lot faster and easier to solve if you recognize that. So for that method, we're going to subtract the 75 over. So we have negative 3y squared equals negative 75. And we'll divide both sides by -3. So that we now have positive y squared equals 25. And finish it up by taking the square root of both sides. But remember, okay, remember here, when we take the square root, we're saying positive and -5 as the square root of 25. So this is also going to be a little bit backwards, and I'm pretty sure it happens on your assignment. So for our answers, okay, we have two answers, but they're for y this time. So we had +5 and -5, and I'm putting it second in my ordered pair because it's my answer for y, not x. All right, so now I'm going to come back up here to my x equals 2y. That's the best equation to plug it back into to solve. It's like the fastest. So we're going to say x is equal to 2 times +5. So x is equal to +10, and I'll put it first in the ordered pair. So we're at 10 and 5. Now we're going to plug in -5. 2 times -5 to get our second answer, which is -10. So our other solution is at -10, -5. All right, so just pay attention to which variable you're solving for and how to set up your solution. All right, this will be our last example. Notice that I jumped to number 7 here. And we have y equals 4x squared minus 29 and y equals x squared minus 17. And I am going to use elimination on this one. I haven't used it very much, so I just want to give one more example. When they do both start with y equals, substitution works very well. Substitution would work very nicely, but I can use elimination on problems that are set up like this as well. So notice I just have, right here, let's highlight it. They both have the y equals. They are matching coefficients of 1. So I just need to figure out how to eliminate them or get them to add to 0. And 1 minus 1 equals 0. So that means I can kind of manipulate this second equation. If I multiply everything in that bottom equation by -1, my y's that are highlighted in yellow there will be opposites and cancel out. So I'm going to multiply everything in that second equation by -1. Okay, so that's -1y equals -x squared plus 17. So I multiplied it by -17 by -1. I'm not changing the top equation, so I'm just copying it back over. Y equals 4x squared minus 29. Okay, for elimination, again, you're adding these two equations together by combining their like terms, so that means like equal signs and everything need to be aligned. Y minus y right here, eliminate to make 0. So we did our job. We got them to cancel out. Keep moving to the right. 4x squared minus 1x squared is 3x squared, and -29 plus 17 would be -12. All right, so then I'm looking at it. It is quadratic, but kind of like that last example we just did. We do not have a b value or a regular x. So the fastest way to solve this one is also with the square roots method. I'm going to add 12 to both sides. So I have 12 is equal to 3x squared. I'm going to finish isolating my x squared value. So I'm dividing both sides by 3. And we have 4 is equal to x squared. And now we can take the square root of both sides. So we get positive and -2 is equal to x. So for our answer, okay, this is going to be two answers again. One answer is +2 for x, and one answer is -2 for x. So we need to get two different y answers. It doesn't really matter which equation you use. I think that this second one looks a little bit more simple. So let's start by plugging in +2. And I'm going to say y is equal to 2 squared minus 17, which would be 4 minus 17, which is going to be, what, -13? Okay, so we have an ordered pair of +2 and -13. And then I'm going to plug in -2 to my x's. So we're going to say y is equal to -2 squared minus 17. But this also is going to equal +4, right? -2 times -2. So we get y equals -13. But these are two different answers because our x's, one's positive and one's negative. So two solutions on that one. Give your best effort at your homework. Hopefully this made sense. I know that some things get lost by not being face-to-face, but again, give it your best effort. Really try. This is some fun algebra stuff, and good luck.